Hello, hello
Hello.
everybody. Thank you for the introduction, Peter, and for the great webinar. And these is inVision days. They are, like always, great to see and watch. Uh, can you see my screen
I can
right
hear
now?
you and can see the screen, and it's already in the presenter mode. So you're ready to start, ready to rumble.
Wonderful. So again, my name is Christian Felsheim. I'm the general manager for the machine vision business at Headwall Photonics. And I'm speaking to you now today out of Germany, actually, out of my home office. Before I go into my talk about hyperspectral imaging inspection and how to make it a solution for your application, please allow me to spend 2 slides on who we are, Headwall Photonics. We are not yet 60 years old, but we finally also made it to 20 years. So we have been established in 2003 as an offspring of Agilent, where this group actually had formed the optical division of Agilent. And the base of the company is making optical components, actually master gratings, holographic master gratings. And that's still a significant business to ours. But starting from there, we have built up a business on hyperspectral imaging, where we became one of the pioneers to bring hyperspectral imaging systems to the market. We have done that quite successfully. However, in 2022, we decided to join the Arsenal Capital Group in order to be enabled to really scale the business, because we are seeing much more market requests. The technology is now really rolling out into many applications, and with the help of Arsenal Capital Partners, we now have much more resources to really serve these applications. And this also allowed us to make 2 exciting acquisitions just the same year. One of which is Holographics, which is also a company making optical components and significantly strengthens our business potential over there. And the other one is Perclass, a technology company which is developed as an offspring of the Technical University of Delft, and developing software to analyze hyperspectral imaging data. Overall, we are about 100 highly skilled employees. We are based in the US, just outside of Boston, in Massachusetts, where we have 3 sites, including the one of Holographics. And then with Perclass, we now also have a subsidiary in Delft in the Netherlands. So that's us. What are we doing? Actually, we have 3 business groups. One is the business we have started with, the OEM optical components and assemblies, where we develop customized gratings, which are the core of any spectrometer, to really serve the spectrometer and the application specifically to their specific requirements. And based on this technology, we are developing spectrometers, which we either sell as an OEM component to other companies, or to build hyperspectral imaging. And these hyperspectral imagers now form 2 additional business units. One is the remote sensing, actually where we have started with doing hyperspectral imaging analysis. And that is about putting hyperspectral imagers on drones, on planes, on satellites, and image objects in the outside world and analyze these objects on the basis of the hyperspectral signature. The other business unit, and that's what I would like to talk most about today, is industrial machine vision. So that's where we bring hyperspectral imaging into applications where it's about inspecting goods. And the goal of all of us in all these divisions is really to make hyperspectral imaging available to users who are not experts, who are not researchers, have not years of experience in hyperspectral imaging, but just want to take advantage of the value that this powerful technology can bring. Now, you have certainly heard a lot already about hyperspectral imaging, but still, please allow me to remind you of two aspects of hyperspectral imaging before I go on. One is about hyperspectral. If you compare different imaging technology, then you are certainly all aware of black and white. So you are getting intensity levels in every single pixel. With a RGB camera or a multi-channel camera, like we just heard in the great presentation of JAI, you are getting not a single plane of information, but now you're getting multiple planes, 3 with an RGB or with a prism camera up to 4 planes, where you now have more information that already help you to better identify objects. Now, with a hyperspectral imaging camera, you're not getting 3 or 4 planes, but hundreds of planes, which form like a fingerprint of the substance you are looking at. And that was really the great advantage of hyperspectral imaging, that you are getting a spectral fingerprint image in every single pixel of your substance. And that allows you to really get to characterizations of your substances, which otherwise wouldn't be possible. The other part of hyperspectral imaging, which is really worth mentioning, is that it is an imaging technology. If you look at such an object as it is presented in these images here, these are just meat cubes on which you see some foreign objects. If you use single point spectrometry, which is very well established in the market, you're having one spot to look at these substances, and that would certainly not allow you to differentiate between these substances. With hyperspectral imaging, you are putting an array of pixels over your substance, which allows you to get to a spatially resolved analysis. So in the end, hyperspectral imaging is nothing else than hundreds of spectrometers in a line. And that gives you certainly data which bears much more information than just imaging or just single point spectrometer, but also it gets you a huge amount of data which now has to be processed and analyzed. In general, however, and before we come to that, hyperspectral imaging is really an enabling inspection technology. So, and this is nicely demonstrated in just these two applications. So in the upper part here, we are looking at adulterations in oregano, where so far, even in larger companies, you would find experts counting these leaves under a binocular. With hyperspectral imaging, you can differentiate between true oregano leaves and those which are adulterated, which are non-oregano, just quickly, just immediately. Or below part would be an estimation of the sugar level in oranges, which is important to analyze, an example for a juice company. And here with hyperspectral imaging, you can do this analysis within seconds. So you have the results on the Brix value as it is of these oranges as it has been displayed in this graph. So hyperspectral imaging is a very fast technology. It provides you immediately actionable result. It is also very flexible and adaptable, as you don't have just a few bands, but the full hyperspectral spectrum, the true fingerprint. You can always adjust to also new types of substance. Imagine you have some variations of your substance, like you often had in the food industry, where you have a new type of apples or a changing harvest. You can easily adapt your analysis to again come to a robust inspection, as you have all these spectrum available. It is contact-free, it is non-destructive. You don't have to cut the oranges in order to get a Brix value. And thus, this makes it perfect for screening of large volumes of goods. Now, how are these data analyzed? And I just want to outline 3 different types of analyzation approaches. The first is pure visualization. So let's look here at a slice of bread, which is moistured. So you see a bit of spots here. And if you look at one single point, like this is here, it is marked in green, you can plot the spectrum of it. And the spectrum which I'm showing to you here is a near spectrum going from 900 to 1700 nanometers and has been acquired with the camera you are seeing in the upper right corner. This is our latest hyperspectral imager. It's the MVC Near. And you could now go by and pick a few bands similar to a multispectral imager and outline the different specialities of the spectra, the peaks and the valleys, and utilize that to generate something like a heat map where you put these different bands in relation to each other. And the software we are using here is from our daughter company, Perglas Mirror, which I will be talking more about on the next slides. And this software provides you with all these types of analysis options you are seeing here on the right-hand corner. And actually, it's even more potential different functional relationships you can select from, which you can now use to generate these heat maps and from there try to better understand of what different type of substances you are looking at. Now, certainly visualization is just a general tool to get a better understanding of your data set. A more relevant analysis method to come into inspection and finally also sorting would be classification. So here we are looking at a sample set of a selection of nuts and raisins, and with it also some foreign objects, like here on the left-hand side, you would have a shell. And you could now, in order to come to a classification within Perglas, it's very easy. You are just defining a set of classes and then label your image. You just go into it and mark what you regard as an almond or the background or a walnut or a raisin. And that is being used to now build a classifier from which you can do an object identification. And here this has been done with our MVX imager, which is actually a complete hyperspectral imaging system because it's an embedded system that includes the processing. So the output of that system is immediately the bounding box of these objects, an ID of which class it has been identified, and then the exact positions, an example on a belt. So a pickup robot would be able to pick up the foreign objects on the belt. However, to come to robust classification models and overall robust analysis models for your inspection solution, it is very important to do proper statistical analysis for the robustness of this data. And that's where the Perglas Mirror software really provides you with a great set of tools to get an understanding on how robust your data is. You can not only analyze like hundreds of different images with many different objects and classes, but you can also precisely analyze on how the precision of your detector is operating. And you can identify where there are errors occurring, and then you can influence also which types of errors are occurring. So in example, you can avoid a miss of a foreign object by pushing the detection to the other side. Another approach of analyzing hyperspectral imaging is regression. And this is also a feature that comes with a Perglas Mirror software. And here is an example being shown where this is being used to estimate the sugar value in grapes. So the process on how this has been done, and this is again being done with the MVC near, so in the spectral range from 900 to 1700 nanometer. The first part is that you are certainly measuring the Brix value of your grapes, so you have a sample set, and then you annotate your hyperspectrally measured image with that sample data. So here this would be a Brix value of 19. And then you certainly have to differentiate on what this Brix value should be applied to. So you have to identify in what part of your image is really the grape under inspection. So what you're seeing here is a bit of the background, which we had labeled in blue. There is a reflection here, which doesn't give you any valid data, which is here white and which we have labeled red over here. And then you have that surface, which really represents the grape itself. So we are now, the next step is to do a classification and an object identification. So we know to which pixels we now have to assign a Brix value, which we have measured before. And from there, having measured certainly many different grapes, you can build your regression model, which is here plotted on the right-hand side. Now, this is the first step. In order to do this, to make this a robust analysis, you have to analyze many, many different grapes. And this has been shown, how this has been done is shown here on this slide. So here on the left-hand side, you would have the grapes that have the images of the grapes that has been measured. In black are those images which have been used for building the regression model. And then here in green, these are the images where there has also a Brix value being measured using another technology. However, they have not been used to build the regression model. And then Perklas is plotting all of this data into, again, a regression plot. Here, the red dots would be the data coming from the test set. The green dots are the data, the red dots are from the training set. The green dots are from the test set. And then the Perklas software provides you with all the statistical information you need in order to identify the robustness of your measurement. So here, these red dots differentiate between the correlation statistics for the test results, for the training results, as well as for the test results. And as you can see, we can achieve, just by looking on the surface of the grape, we can achieve a very good correlation between the hyperspectral imaging and the true sugar content of the grape. Now, Perklas Mirror also offers you further statistical analysis to identify or to get an understanding for the robustness of your analysis. And one very important is the outlier plot, where over every single sample you have measured, the correlation coefficient is being plotted, so you can identify on which samples are outliers. This often helps to identify subsamples in the variety of the objects you identify, in example, different species of grapes. Perklas Mirror also offers other types of plots, an example like an error plot to identify on where any data is being measured which would not fit the model and which would require any type of review. So summarizing that, what is the key for really successful hyperspectral imaging analysis? First of all, and we have heard that from Matthias Kerschagel earlier today, really proper ground truthing of the sample data is key. In the end, hyperspectral imaging analysis is always a correlation of the measured hyperspectral fingerprint with something you have measured with another technology, the ground truth. And the tools I'm showing you here are bringing these different data sets together, forming a correlation, which is the basis of any type of analysis. Now, this certainly fails if you don't have a good ground truthing, and we have seen that in many applications where we have implemented hyperspectral imaging, that in the beginning, we found out that actually the ground truthing technology is not reliable. So this is something really to take care of to get good ground truthing data. The second very important part is that you are really measure a sufficient large enough sample data set. Especially if it goes to biologic material, you have a huge variety of different samples. And in order to catch all these different varieties, you need to make sure that you have a sufficient large enough sample data sets. And that already includes my third point of which is key for a successful hyperspectral imaging analysis, is that you really need to make sure that you cover all the existing varieties, like different types of fruits, different harvest periods to cover, to be included in your analysis. Now, in order to make this, covering all these huge data sets, as well as covering all these existing varieties, may well require that you are doing a lot of hyperspectral imaging data acquisition. And in order to make this simpler and more efficient, we have created packages that really makes it easy for you to acquire a huge amount of data and from there successfully build applications and to develop applications. And these sets come either with linear cameras, so which we would cover from 400 to 1000 nanometer, or a near camera covering from 900 to 1700 nanometers. And we also offer for some applications, an example in the pharmaceutical area or in the plastic sorting area, also cameras in the sphere range from 900 to 2500 nanometers. And these cameras will be mounted on a stage system which include the illumination and comes with a motor-driven stage, and that is controlled by the PairClass Mirror software. So meanwhile, PairClass Mirror, as many of you know, it is no longer just an analysis software package, but it also includes the data acquisition control, the control for the camera as well as for the stage. So these packages are really ready-to-use packages out of the box. They come with high-quality spectrometers. It allows for very efficient data acquisition. The PairClass software brings all the types of analysis you need to build automated models and also do excessive statistical verification to provide you an easy-to-use and start into an application development. Another aspect is that these systems are very easy to transport and to set up. And actually, last slide, with the coming release of PairClass Mirror 5, this will become even more easy. And I just picked out two new features of this new release. And one is the dual spectrometer acquisitions, where you can acquire data from two different wavelength range simultaneously. And the other one is the operator mode, where you can run the whole system just by control the whole system by just use of these three buttons on the stage. You don't need to touch the software any longer and immediately get the summary of your analysis. Thank you very much.